to put every single characteristics that is there, okay? So, first step before I do anything is I've got to factor, simplify, find my domain restrictions, all that good stuff of the one that I'm starting with. Oops. Let me go back up. There we go. I think I got the hang of this now. I'm getting there at least. So we have got to factor, simplify this guy just like we did on our last test. So if I simplify it, that will give me 2 times x squared plus 5x plus 6 over the denominator is going to be x squared plus 3x plus 2. So I'm going to go ahead and factor. The greatest common factor that I took out of the numerator is not going to go anywhere. It is now going to become x and x. I need to know what multiplies to give me 6 and adds to give me 5. It has to be 2 and 3, both of them positive. And the last one on the bottom, what multiplies to give me 2 adds to give me 3. The only factors of 2 are 1 and 2. So that's the only thing that's going to work there. Now, you can already see there one factor, the x plus 2 over the x plus 2, that are going to simplify. Before I do that, I have to find my domain restriction. So it cannot equal -2 and -1. My domain relies on those domain restrictions before there is any simplifying to be done. I always start at -infinity. I will come to the smallest one, which will be -2. Union, -2. This is hard to write small. -1. Union, -1 to infinity. Okay? That is my domain. I'm kind of running out of room, but you guys see that there. Now, we can see x plus 2 and x plus 2. They cancel out, so that means that we are going to have a hole. That also means that the hole is going to be at the value -2. If x plus 2 is the factor that canceled out, I solve for x on that one. That will give me a -2. And I now have to look at the simplified rational expression that I have. So once I take x plus 2 out, these are the only things left over. In order to find the y value of my hole, I plug in -2 for x, and it should give me that y value. Remember, he's a point. Okay? So, -2. If I plug that in, I'm going to do it down here in the corner. It'll be 2 times -2 plus 3 over -2 plus 1. That is going to be -2 plus 3 is 1. 1 times 2 is 2. 2 over -2 plus 1 is going to be 2 over -1. Hold on, I got to do that again in my head. Yes, 2 over 2. -2 plus 1 is -1. So it'll give me -2. So my hole is at the point -2, comma, -2. I'm going to go ahead and put that on my graph. So about right here. This is so hard to draw small, but I'm doing my best here, people. Vertical asymptote. I'm going to look at my denominator for that one, or my only domain restriction that's left over after my hole. So my hole got rid of this domain restriction. So the only one left over is going to be when x equals -1. Okay? Or you can look at the denominator of my new simplified rational. He's the one, if I have a hole, that I need to refer back to. He tells me a lot. So at -1 is my only vertical asymptote. Okay? I'm going to draw as I go, just so I don't leave anything off, but you guys do what you got to do, okay? X-intercepts. Automatically set the simplified rational, its numerator equal to 0. So if I set 2 times x plus 3 equal to 0, that is going to give me an x-intercept at -3, comma, 0. So negative 1, 2, 3, comma, 0. That's right. So you guys get the point. Why I don't know why it's not. There we go. There we go. Negative 3, comma, 0. And now, y-intercept. It is going to be 0, comma, something. There's two ways you can find it. Either you can go back to the original and look at the constants, or plug 0 in for x. If you plug 0 in for x, there will only be the constants left over, and that will be 12 divided by 2. Or you can plug it into your simplified, plug 0 in for x. You should still get the same thing, and it would give you 6, okay? So if I did 2 times 0 plus 3 over 0 plus 1, that will give you 2 times 3 over 1, which is still going to give you 6, okay? The reason we plug in these x values that are 0 or negative 2 is because when those values of x are negative 2 or 0, like our whole, it will always give me out the y value, okay? So at 0, comma, 1, 2, 3, 4, 5, and 6, okay? Now, the last thing I'm looking at is my horizontal asymptote. Here, I'm looking at the degrees. They are equal. 2 over 2. So my horizontal asymptote is at y equals 2. The leading coefficient over leading coefficient is 2 over 1, which just gives me 2. Therefore, there is none when it comes to slant asymptote, and all of my end behavior goes to 2. Okay? So, I think it's looking good. Now we've got to actually do the graphing part, okay? Well, let me go ahead and put my horizontal asymptote at 2. That will come right about here. Now comes in my sign chart. So that's where we put in our vertical asymptotes and our x-intercepts, okay? That is from negative infinity to infinity. It tells me what is happening to my y values when x is a vertical asymptote or an x-intercept. So remember, those are neutral points. Those are where my graphs take turns, okay? So looking at this one, my vertical asymptote is at negative 1, and my x-intercept is net negative 3. The first one, or the smallest one I come to, is negative 3, and the next one would be negative 1. That's the only x-intercept I have is at negative 3, and my only vertical asymptote at negative 1. Now my job is to focus on my y-intercept. He tells me a lot, okay? Y-intercept is 0, comma 6. So if I'm looking at this, 0 falls in this interval between negative 1 and infinity. So looking at my y-intercept, the value of his y is positive, okay? He's important because he's already a point I've plugged in to test, okay? Now, knowing that he's positive, everything has to alternate around him. So we can go ahead and go into the graphing part. So starting on this one, look at your points. If you notice, on the left side, we plot or we look just like we do domain. We go ahead and go from left to right. So going from left to right, from negative infinity, my first stop that I get to is at my negative 3. So all of that should be positive. So that means I start out positive and come to that point, okay? I come along that horizontal asymptote, and I come to that point. Once I hit him, everything from negative 3 to my vertical asymptote of negative 1 is going to be negative. And we can see that it's falling underneath the x-axis. I've got to hit that hole, and I'm going to go down along my vertical asymptote. I can't touch him. I go as close as I can get, but I can't actually touch him. And now if you guys remember, this should be kind of a mirror image. Or if you notice, from negative 1, or that vertical asymptote, to infinity, all of my y values should be positive. So I should be up over here, going through my y-intercept, and I will be a beautiful little reflection of what I had on the other side. So, that is a graph or a sketch with a hole. make sure you take your time. You think about what is affected by my hole. So my x-intercept is going to change. My vertical asymptotes are going to change. Finding that hole is based off the factor that is simplified, okay? And now, I'm tired, it's late. The last question we have here is another sketching one, but luckily for this one, it should go pretty quick. We just have we don't have a hole. If we look at our rational, there's nothing to be, no greatest common factors, no factoring to do. So I just get to go straight ahead, not worry about a hole, just look at my numerator, all that good stuff, and go ahead and graph it. So looking at the domain, in order to find domain, I have to find those domain restrictions, and x cannot equal 2. Or I set my denominator equal to 0. So from negative infinity, that doesn't really click in infinity, to 2, union 2 to infinity, okay? The holes, we just talked about it. There's nothing that can simplify. So if there's nothing, I'm not going to put 0. So don't tell me that your hole is at 0. You are going to literally put none, okay? Vertical asymptote. Vertical asymptote goes with your domain restriction. So it is a line at x equals 2. It's a domain restriction for a reason. That means that my domain cannot touch that line, okay? And he's written like a line, so I have to do x equals 2. Just like x-intercepts and y-intercepts and holes should be written like a point, an ordered pair. X-intercepts, I would set the numerator equal to 0. Now, if you guys look at this, oops, oh crap. Oh, I messed it up. I gotta start over. Oh man, guys. It's too late for this kind of stuff. Hold on. I gotta start over again. Right here, negative infinity to 2. I think that's what I had. It went ahead and erased it. 2 to infinity. X cannot equal 2. Alright, hole, none. Vertical asymptote, x equals 2. I got too excited, freaked me out. So, the numerator, there is only a 3 in the numerator. When I set 3 equal to 0, there is nothing to solve for. There is no x or value to solve through. And 3 is not equal to 0, so we have no x-intercepts, okay? We're going to see why in a second that happens. And the y-intercept, I can either take the constants over the constants, or I can plug 0 in for x. That would leave me with 3 over negative 2, which is just going to be 0, negative 3 halves. Remember, writing him like a point. Horizontal asymptote, I'm looking at the degrees. So, looking at the degrees, the bottom is clearly x to the first power. This guy is, since he's a constant, technically has a 0 degree of x. So the numerator is less than the denominator. That is the rule that I will automatically be y equals to 0. So I won't have a slant asymptote since I have a horizontal asymptote, and all of my end behavior goes to 0. Okay? So now we're going to go ahead and graph our sign chart. That's our vertical asymptotes and x-intercepts. Now, we found out, if we look above, we don't have any x-intercepts, so he doesn't really have to go on to that sign chart. The only thing will be the one vertical asymptote at 2. And we go from negative infinity to positive infinity. If I'm looking at this one, my y-intercept I found is 0, negative 3 halves. So looking on this actual sign chart, 0 falls between negative infinity to 2. The sign of the y-intercept is negative. So that means the other interval has to be positive. And I am going to go ahead and graph everything that I need to graph, okay? So, starting out, domain, I can't really graph that. Hole if I had one, I could graph it. Vertical asymptote, I can go ahead at x equals 2, do my dotted line. Remember, it's dotted because it doesn't really exist. If you made it a solid line, then you're telling me that that's a function. No, it's a dotted line that's kind of acting like a wall. Oh, sorry if you can hear my in-laws clock. It's kind of loud. All right, and then my y-intercept is at 0, negative 3/2, which is about 1.5. So negative. Oh, this is not working. Come on, let's draw. There we go. Went for it. All right. 0, negative 1.5, or 3/2. Horizontal asymptote is y equals 0. So that's my x-axis. Also, the reason why I do not have any x-intercepts, because I will not find, because I will not cross over that x-axis. Not really sure why this became a line right here. It's not letting me delete it, but pretend like that's not there. I'm not really sure what's going on. That line should not be there. But we're going to keep rolling with it. Pretend like that vertical line where our point is not there. Oh, just kidding. This is how tired I am, guys. That is my y-axis. Oh my god. I need to go to bed. Good thing this is the last problem that we have. Okay. Now, from negative infinity to my vertical asymptote of negative 2, according to our sign chart, we should be negative. So I should be below. So I've got to go through my one y-intercept. I will be below. I know the other side is going to look like a reflection, and he is going to be above. There's no points he has to go through. Okay? So this is a long video. Hopefully you can jump through, pause what you need to pause, look through everything, study over them, work through examples, and come to tutoring if you need it, okay? I hope this video actually worked out and you can see everything. These are all questions from your test review, so just look at the number or try to find it or match up which one I did. I took some from the first part of the test review and some from the last part. So it should be good to go. All right. Good luck, guys. Happy studying, and I will see you on test day or in tutoring.